All right. Let's see. Hello, everybody. Welcome back to the channel. Welcome to the stream. Man, I gotta say, I think this is probably the hottest start I've ever got into a stream so far. Look at everybody in the chat. We got Ray in there. We got Kuro Knight. Hey, how's it going? We got Danielle. Danielle, how's it going? Glad to see you here. Of course, Melectrica's over here too, and the old faithful Sebastian. Wow, this is a great start to the stream here. So, I'm pretty excited today because, well, I got a story to tell you, but also, I think the model I have for today is pretty good, and I think you'll very much enjoy it. So, yeah, before we get started, I'll go ahead and just tell my little story here, but I need to get my window over here. So this morning when I was working my other job, I had to get into a meeting that lasted about an hour long, and during that whole time, the puppies were being very much they were being rascals. All right, so usually they're very docile. They're just hanging out being puppies. But I walk out of my office and I see this. So the door was ajar, just like you saw there. And immediately, I see Stella. And look at Stella. She's looking at me like this. So immediately, when you see a dog looking at you like this, sitting, there's something wrong already. So, Stella just with the face of, please, I tried to stop them, but I couldn't, tried to, I guess she tried to talk the other puppies out of making that huge mess over there, but failed. So apparently what happened is, the puppies were outside. They broke in somehow. Not really sure how that happened. Maybe the door was just ajar or something like that. But these little puppies, I tell you, they brought in a pine cone. They brought in this pine cone and just demolished it. So I just walk out of my office and I already have this little mess to clean up. But normally it's just like, not much too much happens for these puppies. They just like to chill and just do whatever. But some days you get the cute puppies, and other days you get the pine cone, and the pine cone crumbles. So that was my little story over here. Hope you enjoyed that. But other than that, what I got going on for you here, let's look up. So kind of related to the puppies is today's model of the day. Hey Ishwanth, what's going on? So today's model of the day is this pet grooming table. So the point of it being, you lower down the table to a height where your dog or your whatever animal, I'm not, if you have a cougar, sure, why not? You can have your animal jump on the top of this, and there's a switch that actuates a linear actuator, which raises the height of this table. And this thing is like super sturdy. Not that Stella's a big dog, but she is the biggest dog we have at around, I would say, 45 pounds. And, this thing's solid as a rock. Just very cool. And I think we'll have a lot of examples of modeling with weldments as well as sheet metal. So all around, a great example. So, let me know what you think of this. And, we'll try and do more. Ooh, let me adjust my chat a little bit. There we go. Now we can actually see some of the new peeps in here. Yep, and there's a good old Yashwanth. Maybe. All right. Well, it's being a little glitchy. Whatever. More OBS things. OBS shows me new things it can do every single day. I tell you. All right. Let's get SolidWorks up. I don't know if you guys know, but I still have the Vaporwave edition splash startup from all the way from CAD model to day 160. So that was like 300 days ago. Oh my god, I've been doing this project for so long. Alright, so normally when I do a CAD model of the day, I have the item in question like right next to me, and I have my calipers, and I'm measuring this. As you saw in the picture, this thing is pretty big and pretty dirty too, since we just store it outside. There's really no way to bring it into my office here, and there's no way I'm putting my computer outside, you know, while I try and stream. So that's not happening. So what I did here was I went outside for like half an hour, and I just made these very sloppy engineering drawings, you know, getting the critical dimensions. I'll probably have to guess at some of the dimensions later, but hopefully I've got enough to get the big picture of it here. So yeah, we'll just see how it goes, you know. So you know, I should be able to flip back to my picture for reference, and I got my dimensions in hand. So, you know, I'm just gonna start from the bottom and work my way up pretty much. So the first component I want to work on is this base. And those of you who are, I guess, experienced in fabrication will know, well, if I were to make that, you know, you just get a long section of this, this is called a box tube or rectangular tube, and just, you know, you saw off the length and you weld it together. You can model this in SOLIDWORKS using the regular set of features if you want, but SOLIDWORKS has a lot of optimized features pertaining to weldments specifically. And I'll show you that here right now when I start. So let's go ahead and grab ourselves a new part file, and I got my little window spawning wherever it wants to, so we'll bring them back into view here. Here, let me turn the music down a little. I feel that it may be a little too loud here, and apparently I have like 50 billion tabs up, so my weldments is right here. So first thing I'm going to do is I'm going to click on this weldment button. So this turns this into a weldment part file. So for those of you who haven't worked with weldments before, so activating this mode does a couple of things. One, it starts to generate cut lists as you model, so you can actually see a list of what you're creating. Number two is that it, instead of having the merge result option on by default, it turns it off by default. And that makes sense because we're trying to think of this into pieces that are eventually put together. So, you know, we'll just turn that on. And you don't have to do it at the very beginning. Like if you start modeling and you realize you need a weldment part, you can click it anytime you want, and it generates the cut list. It's really whenever you're comfortable with it, but you know, this was a very convenient time to talk about it. All right, so I need to, let's see, do I do my profiles first or my layout? Let's do our layout first, because then I can demonstrate another thing. So with my, let's go back, with my base, so you can see, you can of course draw this thing, you know, with all the rectangles, the curves, the fillets and stuff like that. But boiled down, as simple as it goes, you're just drawing these overall the overall paths for these weldments to go along. And that's part of what makes working in the weldment package so simple. So let's maybe we'll start like this and like that. Yeah, I'm gonna have to lock this sketch down, but overall this is our shape. If I go ahead and compare it to this doodad, yeah, it's like an H with 2 bars. So that's what we've got here. Now I can begin to start defining my sketch just like I would any other. So that's always the same. Sir, you did not attach to the things. Let's snap like that. Okay. So this and this would like to be horizontal. Alright, so now we have something that moves like that. So the dimensions I pulled were 22 inches across here. And for this is 34. And the important bit is I actually measured from the center of the profile to the center of the profile. So when we eventually model this, we'll actually have, stuff out to the side and stuff towards the inside. There are options to deal with that. If you want to like draw like the very periphery of your weldment structure, you can do that too. But I just preferred to just denote the centers. So likewise, this gets 6 1/4. We're still underdefined, but I think I can take care of this with perhaps a center line. Like that. And now what? Oh yeah. The midpoint of this and the origin need to be in the same place. Alright, so now we have our sketch fully defined. And before I go any further, I will of course save. Saving is very important. It's always good to just build up that habit, but it's also when SOLIDWORKS starts acting weird, it's almost like how a sailor just knows there's a storm coming. A CAD modeler just knows when SOLIDWORKS is starting to become unstable by how it's acting. But, it's not doing anything now, but this is just out of good habit. This is a grooming table. Grooming table. And I'll just name it something simple. Groom base. There we go. All right, so in regular modeling, you'd use, you draw your sketches out and then go to your, your boss extrude or maybe your revolve. But in weldments, we have this main feature called structural members. And let me show you how it works. So once you get a layout sketch here, the idea is that there are only so many off-the-shelf weldment profiles you can buy, right? You don't want to go out of your way to have some weird box shape. It's usually something very common, at least in the United States. 1 inch by 1 inch, 1 inch by 2 inch, 2 inch by 3 inch. They're kind of discretized in those groups. So here you select the standard, inch for inch, of course, and ISO for metric. And let me see if it has anything for me right now, because SOLIDWORKS actually comes with these by default, but you can actually add your own. So let's see if I'll have to add my own here. So I know I need a rectangular tube, and unfortunately it does not, I need a 1x2. It exists, but not in my SOLIDWORKS right now. So there's two ways we can kind of go about this. These drop-downs actually represent a folder on your hard drive, on your C drive, that these profiles live in, right? But it's always very handy to have your own folder. So, if you just need like one thing here and there, you can say, you can just kind of add it to this list. Like, go find this folder and add it there. But the problem is, like, if you use weldments pretty often, you might want to back up your custom profiles. And, if you have it spread out with the SOLIDWORKS standard ones, it makes it hard to do that. And so I'm going to show you how to set a custom directory for weldments. All right, it looks like I got a comment here. Has there ever been a model for you that would fail to open due to SOLIDWORKS crashing? I have had that before. Plenty of situations that can occur in. A lot of the times, it will say, unable to open your file. Please contact tech support. Indicating corruption, perhaps. Kind of rare, but it does happen. There are ways you can mitigate that, depending if it's like an assembly or a part. But I might go over that at a different time, because that's a deep rabbit hole we can explore. Like, I'm sure as many of you know, I used to work for a SOLIDWORKS reseller doing tech support, so I would hear tons of these cases. So yeah, I think that's a idea for a different time. Yeah, everyone has had that experience. I think that's especially if you've been using SolidWorks for any period of time, it just happens eventually. And especially, I think the most unstable versions of SolidWorks actually happened pretty recently. Like in my opinion, when I was working in tech support, 2017 had a lot of bugs. 2016, a lot of bugs. 2018 was, bugs. And then, they started to get focused and they're like, oh, maybe we should add less features and work on stability and fixing bugs. And we were like, yes, they get it finally. And so I think, 2020 is very stable in my opinion. Not to say I've never had crashes on it, but, the most recent versions of SolidWorks have been, the stablest I've ever seen them. I've been using it since 2015. But yeah. So I don't really see the profile I need. So let's go make a custom folder. So first thing we need to know is where our file locations are. And what you want to do, you go to your options, you go to your where are my file locations? Here it is. And if we go to here, there's actually places where you can show, these are the folders that contain your weldment profiles. No need to be sorry, Corinne. I take any question, and if it's quick to answer, I'll do that. But that's a deep rabbit hole. So it's like, it is what it is. So yeah, that is the standard location for my weldments profile. So let me go ahead and go to my CAD model of the day folder where I contain, all the models of the day thus far. I might even create a new folder, and I'll call this, just to keep it out of the way, 000 custom weldment profiles. So the 000 actually just pushes it to the bottom of the folder because I don't really want it in my way. 2020 is very stable. Rob 2021. Yeah, and that should pop up with the crash reporter. Where it says like, oh, SolidWorks crashed. You want to send a report? It should just have like a picture of my face and then with that quote. Oh man, I'm sure that'll go over well to the people who are experiencing that. All right, so we have our folder. So once we get that, we will go ahead. I copied my file path and I just say add. And I need to paste. Okay, so we're in the weldments profile folder there. So that's added. So I should hit OK. Would you like to make the following changes? Add this. Yes, that's why I did it. So let's go ahead and do that. Go back to structural member, and that's interesting. I kind of expected it to show up over here. Here, let me go look at it for 1 second. So we do have all of these, right? Weldment profiles. Here, I will troubleshoot this for like 5 minutes tops. Okay. So we don't need templates, it's the profiles. It could be I just need to restart SolidWorks, so let me try that. Here we go. VM chiming in. Sometimes files get corrupted when saving is interrupted for some reason. Happens more when working on a network. That's a great point. Because the SolidWorks file structures are built pretty specifically. And of course, well, really with any file, if any part of the file is like deleted, that causes problems with its stability a lot of the times. And honestly, when I worked on tech support, like if a customer was getting tons of corrupt files, First question, are you working over a network? That is literally number one. And if that's the case, well, it's like, well, your connection is probably not stable. I wouldn't say it like that. Just better customer service ways to say that. Um, okay, still not showing up. Why you do this? Why you do this? But yeah, that could be a very common source for corrupt files. Yeah, if this doesn't add, I'll probably just go to the SOLIDWORKS standard one and show you the other way of doing it. So, because I do want to get on with our lives here. So, let's see. I think the easiest way, honestly, I'm gonna grab search everything and type in ANSI inch. Okay, why is the search like this? Details. Okay, so this is probably the folder. All right, so let's take a look at this. So, actually, I'll talk a second about what I just did there. It's very helpful to have this search everything app. I highly recommend it. It's free, and it's like Windows search if it actually worked. And what I like to do a lot is just, if I need to find like a SOLIDWORKS, like anything, like any system file for SOLIDWORKS, I just kind of type in the name and it just gives me the path. It's great. So yeah, angle iron, C channel. So all of these were what appeared here. So angle iron is the first one. Angle iron is the first one. So that's where it is. And now what we can go ahead and do, if I can find my my folder, there we go. Yeah, let's actually add a configuration to this rectangular tube. So you might be wondering, these aren't SOLIDWORKS parts, because SOLIDWORKS part is SLD PRT. This one is SLD LFP. That is a library feature part, and it's what's used by SOLIDWORKS for like library features, that the ones you kind of drag and drop whenever you need. But you can edit these. So in order to do that, let me just minimize this, and simplest way, drag and drop straight into SOLIDWORKS. And that will bring it will bring the the standard SOLIDWORKS library part for editing, and it's great. So you can see here, configurations is actually what drives this whole thing. There's a table here. What's in new? So table, if I double click, it should tell me its secrets. Okay, I think I'll do this from here. So I can actually go here and say, oh, this is great, actually. So it looks like it's the big dimension followed by the small. So this is a 2 by, be consistent, by 1 by, and it's not going to be 1/4 of an inch. Like, Christ, that's way too much. It's going to be a 1/16. And then I can just go here. Yeah, spill your secrets for me, little table. So the V leg is 2, and the H leg is 1. Apply. Okay. So if I click on this, this should adjust. Adjust. Do you have to rebuild? No. Oh, no. Zero thickness geometry. Oh, this is probably too thick. There we go. Yeah, let's do that. This configuration. Yeah, so what was happening there is that the values that I put here, the fillet was way too big, so this line turned into 0 length, and that's why I was throwing a fit. So let's sabade. Yeah, I might throw this. I might have to throw this in a different folder. You can live in there, and then I'll just drag and drop because of permissions. But let me give this a test before I do that. So we get thick, thick with 2 C's, thick with 3 C's, and then our actual profile. So this is looking good. We got past it here. And so can exit that with a save. And so one goes here. And I need to go back into my this. So replace. Admin privileges. Ooh, scary. So scary, you guys. Alright, so what do we got here? ANSI inch, rectangular tube, and there's our new standard. So there's a 2x1. Alright, and now we get to see some actual solid geometry now. Hooray. So the way you want to pick groups is by what SOLIDWORKS likes to call trim order. So as you can probably imagine, these tubes have thickness to them. And so you can't have a tube go all the way to the length of this and this because they're kind of intersect each other at this point here. So the question is, who gets the spot? So the things that you pick first is gets higher, what's called trim order. So it gets higher priority. So the trim order of our thing here, if I may go back to this doodad. Yeah, so you see at that corner, the weldments on the side get priority. The ones in the middle don't have secondary priority. So I should pick these ones first. So there's 1, there's 2. And at this point, I want a new group. So groups are only formed with parallel lines, which these are, or a loop. So if you have like a square, you can pick all of them for the same group. But I need a new group. So then I pick these and that. And you can see at that corner, since I picked these ones first, they get the higher privilege, the higher trim order, and they get to occupy this little pink spot before this one. You can adjust this on the go too. If you click the pink dot, you can actually adjust what happens to the corner treatment. So it says group 1, trim order 1. If I set this to trim order 2, and then this to 1, you can see the horizontal member has priority. It gets the pink dot, and it just breaks this thing into 2. So it's really pretty powerful if you plan ahead of time and if you plan ahead of time, it works out pretty well. Hey Avita, what's going on? Welcome to the stream. We're just doing some weldments. Glad you can join us. But yeah, that's all I need. That all to just do that in like, a couple of features. So save. So that is not all we got. We also have a hole that we need to do in our base. Will be part of our mechanism here. Yeah, this one. That is where I believe where the center of the linear actuator goes. So, I can just grab the front plane. I gotta change my little setting here. Set to Genshin Impact. Not now, Paimon. I'm doing some modeling. There you go. Set it to red. Front. Okay. Now there we go. Currently stuck on cut lists. Oh, we can totally review that, man. Oops. Yeah, they can be kind of tricky sometimes. says 0.75. And that measurement is to this edge. That's how I measured it. And that is 20.5. And that should fully define it. And then I could just say extrude cut through all both. So, you know, regular features still work on a weldment part. And I think that'll be it for this. You know, I'm not going to go too crazy because I've spent already a little bit of time talking about weldment profiles. Oh, Sebastian asked an awesome question, and this I can demonstrate. How do you change the orientation of the structures? So he's talking about, probably, and feel free to correct me if I misunderstood, these just kind of knew they were vertical, right? So what if you want them horizontal? So I'll tell you what you do. You go back into your weldment feature here. You scroll down, and there's actually a box here where you can specify a rotation. So if I say put group 1 to be 90, and then group 2 to also be 90, you know, then I hit OK. Now they're flat. So that's how you do that. And yeah, the cut extrude fails, but we'll fix that. And additionally, you know, if you press locate profile, it'll zoom you into the profile. So remember how I said I like to draw the center lines of where the profile is going? Well, if this was like the top corner, you can actually just click on this here, and it just scoots up to the top corner just like that. And in that way, you can... there's a lot of nuance you can have with your weldments here. And yeah, let me put these back. So 0, group 2, 0. Yeah. So cut extrude should come back here, and we should be all Gucci. Vito, how would you say is the best way to keep in touch with all the elements of SolidWorks? I feel like I go through cycles in terms of proficiency. Surfacing is alien stuff to me. Well, I always say like the best the best way is practice. You know, I've said that tons of times. But honestly, what you're doing right now is really going to be good for you because you know, why I also like this particular thing to model for today was also to keep my skills sharp because it's kind of like the opposite for me where I really like to do everything with surfacing, but weldments and sheet metal don't get a lot of attention from me typically. So it's with stuff like this where you know, in your job duties, it'll depend on you know, what your job is supposed to do. Maybe you're able to shuffle some things around and try something new with SolidWorks. But other than that, just try these little projects back at home. Like they don't have to be full-blown mechanisms like I'm doing here, but just like saying like, here, can I make this frame in weldments? Just try it out. You know, can I create this like surface of a computer mouse? There's like a ton of like little exercises online where it's just like, here, just create this one surface, and you know that'll keep you sharp. And then just watching my stream like this, you know, I'm always spilling the secrets of how I like to do my SolidWorks. All right, so this is pretty good. We need a new part now. So I'm doing bottom-up assembly modeling, and I think I'll do this with sheet metal. So I'm going to grab the top plane, and this sheet metal box will probably have... Yeah, it's like a... I don't know if you can see that. Here, let me change my little scene there. It's a sheet metal box. It has some features on it. And there's my very, very crummy drawing. So it's like a box with, you know, 3 of the sides missing. So what I'm going to do, make sure I change it back. There we go. Let's get a center rectangle like this, and then just turn this into construction. Boom, there you go. That's the shape. So don't forget, you have tons of sketch entities, and a lot of them are very close to what you need. So be sure to not count them out. Like I could have drawn these three lines one at a time, but this basically had it for me. All right, so that wants to be 6. And eventually this will get another configuration, but I'll worry about that when the time comes. 7.75, we go to sheet metal. So here's where the fun begins. Base flange or tab. So sheet metal, and the main thing there is base flange. So what I'll do here, you can set the thickness, but let's see. Oh yeah, I don't have a material applied. Oh, use gauge table. That's what I was looking for. So SOLIDWORKS comes with a bunch of gauge tables. So let's use the sample table for steel, because that thing is pretty rusty, so I'm very sure it is steel. And we don't want 3 gauge. That's extra thick. 15 gauge is actually pretty close. I need 0.0625. What about 16 gauge? 2. So I guess we're gonna make this thing out of 15 gauge. Vito, what do you got? When the time for assembly comes, maybe touch on how to use the new part option from within assembly. I find it hard to navigate to get my plane and setting the origin, and end up just making it normally. Oh, that's I'm glad you brought that up, because now I can I'll actually show you how to do that when we make one of these last parts here. So I'll do that later. Awesome suggestion though. The overall height of this is 14. So there's our sheet metal thingy. Okay, and in this, there is a boss that supports. There is a boss that supports the axle that goes through. So draw 2 circles, make them equal. They're both 1. 1. You can set 1 to be vertical. Like that. And these are 6 apart from each other. Oh, you need to scoot down. These are 0.75. These are 450. Alright, and that should be fully defined for that. So I can not merge. Oh, I didn't measure their thickness, but I'm just going to guess they're 1/2 inch. Okay. So we'll get that mirror. Okay. So far, so good. And now, I think I'm going to borrow these same sketches. Let's get on the right plane here. Oops, can you... Oh, alright. Yeah, I think that's a bug. Stable version, guys. Yeah, because that's happened to me like in every single stream when I try and put a circle on a center point. VM, random question. When you're dimensioning something, the pop-up window where you enter the value is wider than usual. Is there any way to have it like that permanently? Honestly, that's a good question. Oh, yeah. I didn't really even notice. I wonder if I put it shorter, just... It might just have memory, honestly. Here, let's put it ridiculously long like that. And let's just see if it appears in the future parts that I model. Let's do that test, because the answer to that, I'm not sure, but I think it has memory. Okay. So I'm just gonna call this groom box. And let's get, so let me rename this configuration. Go to properties. So this is the dimensions of the one that is at the towards the bottom. That is to say, it is this box here, and I'm probably gonna neglect this cut here. You know, it doesn't really add anything to the design. But we'll add a new configuration called top, and I should be able to click this, double click that with our really long box, and the value of this is supposed to be 9, but be careful, don't hit that check just yet if you're doing configurations. Hold it, partner. You go over here and make sure you set the scope to just this configuration. This trips up tons of people. Now you hit OK. And always good to run a little test. So bottom, nothing changed. Top, there we go. So you can see the top one is just a bit wider than the bottom. And that rebuilds just as expected. There we go. All right, onwards and upwards. Start yet a new part. Vito saying, what would you say is the better extrude option? Up to next versus up to surface? The end surface is the same. Pros and cons. Bro, that's another great question here. Let me see if I can try and work that into this next one here. Let me see. Let me think. All right, how about I start modeling it, and then if I see a good opportunity, I will strike and answer your question. So this next component is going to be the actual linkages. It's this. So this, just like the boxes, will have configurations because one of them, you know, you can see does not have a hole, has rust, but no hole. And then this one has a through hole in which the linear actuator actually is able to put its linkage through. It's plunger through, for lack of a better term. I know there's a word for it, but I literally can't think of it. All right, I think I'll do this kind of similar to how I did the other one. So again, it is like a box with, you know, a couple of these removed, but they also have these little tabs. So I'll just draw these out like that. And it's okay to have lines on top of each other like that, as long as, you know, this one is a construction line and not like a solid line. All right, but this has a width of 7. No, why didn't you do that? 7. So I guess that to answer the other question that I got, looks like the size of the box persists if you just manually resize it. So I'm just gonna put it small again. What does that need to be? 2? Sure, why not? These flanges, 1/2 inch. Sure. Oh, not 50 thou, 500. There we go. Now we're getting somewhere. Now we're getting somewhere. Again, be a sheet metal part with an overall length 19 3/4. Mid. I said mid. There we go. We can use our gauge table. Sample table. And we'll be consistent and say it is 15 gauge. Yeah, and also very cool about the sheet metal. Notice that, you know, I can draw these with perfectly sharp corners, and we'll put the radii on there for you. Very cool. You can set the option for that like here. And I might need a flange to box off the ends. Yeah, let's do this. Yeah, I'm gonna need an edge flange. So from here to here. So let me see if I can, well, no, there's nothing. There's like end conditions for this feature too, but nothing particularly interesting. Okay. Okay, I know I don't want to spend too much time on this, but can we, yeah, have a relief, please? Can I see the relief? There we go. Let's try that. I might have to trim, what's it called? Trim side bends. That's the option that needs to be on. That should prevent this weirdness from happening. There we go. That's more like it. Good old trim side bends. Oh, it looks like it's intersecting a little bit. Should be able to change this to be material on the outside. Yeah, that's pretty good. So this will be Groom. Oh, that's all caps now. Deal with it. Groom link. You know, not trying to overthink it with the names, you know. Okay, now I want the holes, and it has a, what is your problem? Part intersects itself after bend operations. Still? Oops. I'll try one more thing, but if it just keeps being angry, I'll probably just move on. Bend towards the outside. Okay, that fixed it. All right. We made the part slightly longer, and that's totally cool with me. Because the critical dimension is where the links actually, you know, where the pins actually are, you know? So in this, we will have first some standoffs. And drawing circles like a drunk man. Equal. Might even just connect them with a center line. Midpoint with the origin. And then the distance is 18. And this is the one that matters. Size. Let's do 3/4. Yeah, there we go. Do up to next on one. Up to next on the other. And, you know, I'm thinking about that other question that I got, but I don't think this is still a great example. So I'll move on. I'll probably make up a quick example at the end. Okay, and then we need the holes now. So, okay, so these circles are just fine. Equal 0.5 and extrude cut through all both. And there's our link. So we need two variants of this. So one of them, I'm going to call connected because that's where the actuator connects to. Yeah, ooh, not derived. I need to rename. Can I rename from here? No. Properties. So I'm just going to call connected. add. And then one is through hole. Alright, so I'm going to do the through hole first because that's just, you know, one feature and I can just suppress that. Actually, yeah, this is a through hole configuration. And it is a rectangle, like the one you see here, with chamfers. That's fine. Oh. I'll set their size to be 1. Okay, we can change that to 1, and we should... Nope, they broke. Why did I even bother doing this? Yeah, I thought I would just use sketch chamfers rather than feature chamfers just to make... So I don't have to select these tiny edges, you know. Alright, fine. Be that way. It was your turn in the spotlight, sketch chamfer, but you're being annoying, so I had to cut you. I'll just add them in the features. No biggie. 5.25. Okay. So this too, oh, this is gonna be a little tough. Well, it's not too critical because this hole's gaping, so it's not like it's a tight fit or anything. So if I get it off by a thickness or something, it'll be fine. Extruded cut through all. You're going the wrong way, son. Go the other way. I might be able to use the break corner. So if I go to sheet metal, go to corners, no, not corner relief. Break corner. Can I break? I can't break internal corners, can I? No. I guess it's only external. So if I click on this, you see it's breaking them with a chamfer. So I think I'm just gonna have to use a regular chamfer. All right, wait. I got a cool trick to show you guys. Yeah, I'll show you something pretty cool here. And before I do that, let me answer Avito's question. How often does SolidWorks act stubborn and force you to school it by going an alternative route? I love that question. I would say practically every part. There is something like, there is a way I want to do it, and I have to just use the alternative route. Not necessarily a bad thing, because some of it's like, oh, instead of using this, I'm just gonna have to, instead of doing it in 1 step, it's 2 steps. So it's, most of the time it's not a big deal. It's not like, oh, it's just like I hit a brick wall and I can't continue anymore. But I'd say almost every time, I would say. Man. Sometimes I can't fault it because it's just like such a huge and complex program. All right, so back to my super cool tip that I bet you've never heard before. So I want to add chamfers to this. I've decided, but well, not yet. If I go to chamfer, you know, I have to go and painstakingly pick each one of them. And let me do that again, and just to show you, yeah, you see like that. If you click on it, you know, that it shows you the preview, and that's it. Fillet, on the other hand, is a little different. So let me go to fillet instead. And if I click this one, you get this kind of super duper edge selector. It's awesome here. So let me zoom out and show you what I mean. Zoom out enough that I can actually still pick it, but then you see the effect. So if I go ahead, oh my gosh, edge filter. So if I click that and then go here, you can see in pink on the other 4 corners, it's saying, if you click this option, I'll pick those other 3 corners for you, so you don't have to go and pick every single one. So if I click that, you see the preview appears on basically every corner, and this works for corners of, you know, any size. So if you have a star-shaped pattern, it'll pick like the 10 or 12 edges you got there, and so on and so forth. Very powerful. For some reason, chamfer does not have this little selection toolbar. Only the fillet does. So how does this helpful if I want a chamfer at the end? Well, I'm going to apply a fillet anyway, like this, and then go back, and then right click on fillet, and then say convert fillet to chamfer. I probably should change the size of it. I don't think I ever specified its original size, but there you go. So that is both how to use the selection toolbar of fillet and how to convert a fillet into a chamfer. So if you knew this already, let me know, because I came up with this like a while ago, and I don't get to demonstrate it very often. It's using the selection capabilities of fillet, but then you just transform it into a chamfer afterwards. So yeah. So this is me schooling SolidWorks. You know, got to show it what's what. So through hole, so connected. Yeah, we'll have those, that feature gone. So I'll go ahead. And let me see what I want to do here. How do I want to do this? Because I don't feel like creating a new plane. But I do need to add like a little L bracket thingy. Alright, this is kind of the lazy way of doing it, but I'm here for it. So this is 1 inch long, 5 like that. Wow, I never gave this thing an overall height, which is fine. We'll deal with it. Grabbing this, that's 0.5, and then this is 12 inches from the end. Fully defined, and gee, I don't know, I'll just give that a height of 2. Uncheck merge result. So this is where I want a bracket to be, where this block is. It's going to be this face and the face that is butting up against the inside of our little doodad. And so how does this help us? Well, be wary that sheet metal actually has a convert to sheet metal function. And let me show you how that works here. So what you do is you select the bottom, what you want to consider your first flange. So I'll do this one. And then you pick what edges you want to bend. So if I pick this, you can see it's kind of just wrapping around this cube. And you can keep going. Like I can select this, you know, it automatically detects that, well, if these two are bend edges, then this has to be a rip edge. That is an edge where you have to weld it together. Because if it wasn't, it's not a sheet metal part anymore. But I don't want that, so I'll just unselect that. I just want these two. And you should consume the body, so I'll keep that. I'll keep that unchecked, but I do want to reverse the thickness. Because remember, it's butting right up against it. And yeah, I don't think I need any particular options. And there we go. I got my bracket exactly where I needed it to go. And additionally, I should be able to just simply mirror like that. There we go. And then I can punch a hole through that, and that's where our actuator will go through. My question alternative method just got answered with a demo. So cool. I'm glad you're enjoying yourself here. That was my my little trademark when I taught official classes in SolidWorks. It's just like honestly, it's like me personally, I learn by example. So it's one thing to say, oh, Fillet has a selection manager. It's another thing to like be in a situation, you know, kind of like really absorb the problem, and then, you know, you unwrap how that solution helps you with your CAD model. I think that is much more valuable than just me telling him like, hey, just use the selection manager and fill it. Call it a day. And what's nice here is that you're on my channel. I get to stream for as long as I want. It's not like in class, like, oh, I can only stream for an hour. It's like I can go as long as I want. The videos will be on YouTube. You can scrub back through them and, enjoy them at your leisure. So, yeah. No, I'm just really glad you're having a good time. Yeah, Vito, the selection filters are really so good. Before I sketch, I'm just going to be lazy and say point. If I click this, I just want to grab a centroid. Okay. 0.5. And this will be interesting. Let's see how this works. Up to next. Up to next. Because I don't want to punch all the way through, just enough through these brackets. And what I might even do, let's do a corner trim. Oh, I should actually do this before mirroring. Corner trim. Like that. Okay. And that should be the two linkages. So let's test. So connected, and then the through hole should just be the hole with the others suppressed. Yep, this is working perfectly. All right, what else? What else? We need a top, which I just realized is identical to the bottom. So let's get let's get another where are my windows? Go back to the base. I need a version of this that supports the top panel of I guess wood, and I'll just add a configuration. Not before renaming this. Bottom, add, top. And I guess, while I'm here, I guess I'll answer, well, one of you mentioned that, you were working on cut lists. I'll, touch briefly on that. Basically what, in a weldment's part file, and also in sheet metal too, sheet metal parts will keep cut lists. It will make a list of every unique part in your weldment's file. And keyword unique here. So, you might ask, like, why is there only 2 things showing up here when there's clearly 4 members here? Well, 2 of them are identical, and the other 2 are identical to each other. So that's 2 unique ones. And with that, you can see all kinds of fun properties and info you can put into SOLIDWORKS drawing. I won't get into that here, but for example, for this particular tube, it knows its length is 22. It knows that the angles are cut at a 0-degree angle, as opposed to like a 45-degree angle if you're trying to miter them together. But it also knows the total length you'll need to build this, which is 110, and that's in inches. So SOLIDWORKS is saying total length between these two, you see both of them are 110. It says you need 110 inches of rectangular tube to build this. So it gives you all sorts of cool things to, make your workflow a bit easier if you do a lot of welding do a lot of welding related projects. Here we go. So the top, as far as I can tell, does not have does not have such a hole. So I will suppress this. Alright, so what I'll do is I'll right click on sketch 1 and say configure feature, which will bring up this sketch. But it's only letting me suppress it. I want to change the actual value. So if I click on, let's try double click. Double click on sketch 1. I can actually double click on each of these and then change them in every configuration I got here. So for the top, the center to center distance is now 10. The overall length is still 34, but then this goes down to 20. Man, this is a great part. You know, if you want to, you know, take a tour of like the, you know, the Wellman's functionality and other stuff and configurations. Yep, so there's the bottom with the hole, and then top should change, and then the hole goes away. That's done. Let's see. How do I want to do this? Okay. Yeah, also, so I'll do one more component here, I think. And then the last one is the actual top. And I'll actually save that for the question that I believe Avito asked earlier. And forgive me if I got that wrong. Someone asked me earlier, you know, how do you use the new part functionality in an assembly? So that'll be the perfect opportunity to do that. But before we get to an assembly, just one more part, and this will be very quick, I promise. So again, it's kind of like a C channel. So if I may switch my webcam and look at this. Look at this. This is my masterpiece. I know you're all jealous of my freehand skills. It's totally not why I never was inspired to learn SolidWorks or anything like that. No siree. But you know, I'm making like a C channel shaped thing, and to do that, well, again, remember, a C channel is like a box without one of the sides. There's your C channel, and 2.5 and 1.5. And then from here I can just give it to an extrude, and you might be confused because like, isn't this open? Like, well, if you feed an open sketch to the extrude, you get a thin feature. And that's exactly what we want to use here. So I want the thickness to go the other way, and you can actually auto-fill at the corners, although it doesn't give you a preview for some weird reason. Let's do 1/4 of an inch, and say mid-plane 10. If I hit OK, there's our part. So why didn't I use a weldment feature with this? That's the elephant in the room right now. I just stood on this soapbox for the past like hour saying weldments is great, and then now I'm actively ignoring it. Well, the answer is if you don't need the fancy really what you use weldments for is like you need to trim, you need to get cut lists and evaluate that information. And there's more features, and I won't go into that, but those are the two main benefits of using weldments. If you don't need to use any of that, a lot of the times, if it's just one piece like this, you know, a thin extrude can take care of it most of the time. Just gonna make that smaller. There we go. So, you know, it's just a matter of a use case. C-Chen. Maybe a smart thing to have a C channel saved in your custom weldments profile. Absolutely. Additionally, I will show you this really quick. I won't go through the whole process, but if you go into Design Library, this little dude here, go to, I believe, 3D Content Central. Where is this? No, it's SolidWorks content, excuse me. I remember now. SolidWorks weldments. So you can actually download the full. So if you use weldments a lot, you can you see when I hover over, it says Control click to download the zip file. You know, I can just throw that wherever I want, and it downloads like a full huge library of weldments. There's probably a C channel in there. The reason they don't just give this to you is because it would make SolidWorks take even longer to install, if you can even believe that, right? You know, everyone likes to talk about how long SolidWorks takes to install, like an entire hour sometimes. But yeah, the less data you have, the faster it installs. So weldments, that's a la carte, but it's completely free, and it just does it. You just drop it into your weldments folder, and it's all good to go. I might just cancel it because it might be I don't want it to affect my stream because I'm using bandwidth for that. So I'll just leave that alone. Just a good to know for that. But yeah, I think it's time to start assembling. So from this, let's make a new assembly. So we'll start with the groom base, the bottom configuration, and just hit the check, which will place it right there. What do I need? I need a groom box, the bottom one, like that. And yeah, because my brain is pea size, I already forgot what orientation it needs to go. Okay, so boss is to the outside, and I have this distance here, so come on, my dude. All right, so mate. Want to know another cool trick? You know, I need to mate the other underside, but I don't feel like just rotating it around. If you're in the mate tool and you hover over a face and hit the Alt key, watch what happens. It's very subtle, but it actually hid that face away, and you can actually select the bottom from the inside, if that makes any sense. It's a little nutty. A very cool trick. From this groom box, I need... Oh god, nope, it's the right plane. There we go, the right plane of that. I'll do it with the right plane of the groom. Oh, drat. I guess with the front plane of that. Let's try again. There we go. That goes like that, and I have the value for this somewhere, I promise. Yeah, so from here to here. Yo, hit me up with that distance dimension, dog. There we go. Distance. 7. And let's give this a place to live. Grooming table. Guys, I'm really liking how this stream is coming out. I got to answer a bunch of great questions, and I think the examples here have been great. Yeah, so for those of you who are watching, especially, and a huge, even bigger thank you to those who are participating in the chat. You know, you're part of what is making this so great. So I appreciate that. Okay. So now I need links. So this is the connected, and I gotta be careful with the orientation of this one. Oops, yeah. So with this, I'll say concentric. Oh no. Alright, we're good. And now I would like to center this along this pocket, basically. And you could do that by measuring the distance, subtract the distance of this, divide by 2, yada yada yada. That's one thing. But you can use a width mate, and if you've never used it before, it's a great little tool. So watch this. If you go to your mate, go to advanced mates, then go to width. So you're going to select 2 sets of faces. So one of them is going to be the width, which is the wide part, and then the tab, which is the narrow. And we'll center the tab in the width. So the width, remember width means wide, so from here to here, and the tab is from here to here. And then you can see it centers it. It centers it about there, and you know that is stuck in place. Oh, you're about to join/host your first SolidWorks user group? Man, that's awesome. And I've been super on the edge about that myself because like I love user groups. When I lived in New Jersey, you know, I would go present practically every month in a user group or something. But ever since I moved to South Florida, there was actually no user groups down here. Although the reseller down here, Trimec, has been trying to convince me to start my own and become the leader of that. But I feel that honor should go to someone a bit more responsible than I am. Oh yeah, and Avito, you're ahead of me. Yeah, I was gonna show that next time. So Avito's tip here, quick tip: select 4 faces into planes, and it will show the width mate option. Absolutely, my friend. Watch this. So that trick, by the way, if you hold down Control and take note on the right side of your screen on the stream, you can actually see what keys I'm holding down. So if you're not sure, you can rewind the video and see if I do any weird stuff or shortcuts. But yeah, if you hold down Control, click, and drag, you produce a copy of the part in an assembly. Very useful. Then I can click and say you need to be in the through-hole style. There we go. And rinse and repeat. And now this might be a little tricky, but we can still do this. Using Avito's tip, select 1 face, hold down Control, select 2, select 3, rotate, hold down Control, select 4, and when I let go, width mate appears in the shortcut menu. So yeah, it lives there. It's great. There we go. Ray chiming in, Rob, I would love to see an example of the make independent command in an assembly. I assume it's a lot like save as copy. I'll be honest with you guys, I have never used that command before. Honestly, I might just look at it and play around with it and try to discover its secrets. You know, that's kind of one of the most important attitudes you can have when just being a CAD designer, not even only for SolidWorks, but for anything, or just in life. It's just like, you know, never think you're done learning. You know, I've taught hundreds of classes, you know, hundreds of students. I've had my YouTube channel for 5 years. Just keep your ears open and you you learn new stuff like that, you know? I learn new stuff every day. So it's going to be tempting to bind this with a parallel mate, right? But I think that will be redundant because what I really need is just a copy of this, change the configuration to top, flip this around, and by virtue of this just being a four-link mechanism, like a four bar mechanism with 2 links of the same length, it should drive that on its own. Okay, so that with this. What is the shortcut for collapse all or collapse current part in the browser? Breakthrough moment. Ooh, oh wait, so are you talking about this? Hang on, so let me just mess up my thing. Like that? Just to collapse everything? That is Shift and C. C for collapse. Shift C. You know, if you have a bunch of these things open, just pick any line item, Shift C, collapses it all down. What I do not know is if there's an inverse option, because there's sometimes where it's just I do want to like expand pretty much everything, So there, as far as I know, there's no expand all. Not that I need to use it that often, but yeah, collapse all very useful. You know, just cleans up your workspace very, very quick. Yeah, and looks like we'll need another width for this guy. And I think only one because we don't want it to be redundant. So now, yes, this is correct. This is what I'm talking about. All right, this is looking great. This is awesome. Honestly, part of me wants to just kind of lock this so it stops moving. But yeah. Expand all is needed for selecting planes or something when mating. I agree. That's probably my use case as well. So, yeah, I always like figure out the stuff that I want to tell like the enhancement team. Just like these little things. It's like, come on, man. It's just, I'm not a software engineer, but this has got to be like one line of code. It's just something like, you're kind of doing it already. You have a collapse all. Can I just have the opposite? Can I have expand all, please? And I think I already tried this before. Yeah, it's not Shift E. Yeah, that doesn't do anything. It did bring me to my equation folder, which is interesting. Yeah, I don't know if that really did anything. But yeah, as far as I know, that does not exist. Let's grab a copy of this and change this to top. Alrighty then. So I'm gonna get this thickness face with this. If I will play around with it and see what it does. Oh, make independent. That's save components with new name. Do you want to save and replace the selected components with a new name? Here, let me Here, I need something as tribute. Oh no, that's not what I meant. Just this one. Okay. What happens if I make you independent? Go and be independent, my friend. Groombox 2? Question mark? That is really interesting. So it saves it as a new part. Oh, bro, I just figured it out. I think I figured it out here. Let me get my neurons in a line and I will tell you why I think that exists. So, for example, man, I actually could have used this. We're taking a detour. Hang on. I need to know. I really need to know. Let's go to my Instagram. Alright, and there was a model the day where I think I could have used that. We're taking a little break here. Sir, I am looking for the bellows that I did. Yes, this one, 453. Yeah, basically an alternative to configurations, but there's something that would force the use of this. So let me look at, so what CAD model the day of this? So this was 254. I should have that. Open. Let's go all the way down to 254. Yeah, this is where I could have used it. Because if you look at this, yeah, because if you look at this motion study, we have two flexible parts here that I animated. So you can see as this one is compressing, this bellows is expanding. So that was not trivial to do. And the reason I say that is because this mode of motion study with flexible parts depends on rebuilding the part over and over again. So I pose this question, this kind of rhetorical question. If this is in its own part file and it's rebuilding to currently look like this, like squished, how is this rebuilding to look a different way at the exact same time? And the answer to that is you can't. You need an entirely different copy of this bellows to be in a different rebuild state. So the way I made this animation is there's two copies of those bellows and they rebuild independently of each other. And that's what gives this thing its motion. All right, you are taking a long time to rebuild. I guess this let's see if I hit the good old stop. See if it wants to stop. But you see in the tree here, I have flexible bellows 1 and flexible bellows dash copy. I made the copy manually. But it would have been really cool and actually faster if I just copied it, right click, made independent, and then I have basically an independent copy. Because if you consider its rebuild state right now and you open it, you see it's expanded right now. But if I go to this guy, squish. They can't be both at the same time. So, Ray, you taught me something here. I hope that makes sense to you guys. Maybe maybe at a different time I'll go through an actual like example with that. But that's a place where I could have used that. Make independent, I tell you. Yeah, I could have copied and just say make independent. Avito, basically the buffer can only be at one state at a time, pretty much. Yeah, because I have basically sketches that stretch and shrink based on where the assembly has moved, and you can only rebuild to be one shape at any given frame. And maybe I'll show you. Just this one takes so long to rebuild. Maybe in a different assembly. Don't save. Yeah, let's get back to our other doodad though. As you see, I am very easily distracted, but honestly, it can be a good thing sometimes. All right, so front with front. There we go. And of course, we just have this offset. Yep, Ray chiming in. I think it's a form of save as, copy, and replace in one command. Precisely. Because I did what you just described there in the bellows example. You know, I just said save as, copy, did all those steps, brought it in, but it would have been so much easier. Copy, right click, make the one independent. Good to go. It's very slick. You learn something new every day. All right, so I am missing one more dimension here. 8 is the number. So from here to here, distance 8. All right, so we'll give that a good old save. We're basically almost ready. I might draw something real. I don't want to go too crazy with like the actuator because this is going on so long already. I might just draw like a bottle jack and just have that like, oh, there's our actuator. It'll do the same thing though. But to answer a question I got previously, so how do you use the new part command from within assembly? So if you don't know what he's talking about, if you go to insert components but you hit the drop down arrow here, you get, well, the regular insert components, but you also get new part. And this is the foundation of using the top-down assembly modeling technique, where you can basically draw parts that are on top of one another, or that actually can even change with it can actually even change with how the other parts change positions. Just like the bellows, that when one arm goes up, it stretches. So you can do that all with this. So new parts, I'll show you. So I'm going to click on new part. Everything turns gray. I haven't clicked anything yet. Look at how my cursor looks like right now. It's just standing there menacingly with a check mark. What do you mean, cursor, when you mean check mark? And it's understandable to be stuck here. So what it's asking you to do now is to pick where the starting plane is. Where do you want to draw your first sketch? So in our case, we're drawing the tabletop with the wood table, right? So a good place that I would like to draw is maybe starting on top of one of these beams. So then I'll click there. SOLIDWORKS has already interpreted that I want to draw on that for my sketch plane, and now it turns everything transparent so I can focus on the actual thing. So now I can go grab a rectangle like that. So this is a way of modeling, but I can also see the overall, what the overall assembly is. So if I was drawing this tabletop by itself, I might just give it a width and a height, right? But what if you want, for example, an offset to this? So I just want it to be half an inch wider than that. You can't really specify this if it's in a part by itself, but you can if you go through new part and then go into this top-down assembly mode. So I'll just even leave it like that and give this an overall height of 24, I believe. Extrude. Yep. And say, oh, I wanted to fillet. So again, using our selection, so I'll grab one edge and say connect it to start face. Grabs the others. And we'll bump that to maybe 2 inches. So you have something like that. You know, maybe just to make it a little bit softer. Not that small. Just do an eighth. And I can exit, and that's it. And so what happens when I start moving this thing around? This is important. Let's check. Oh, it follows. But surely I must be able to just yank this off, right? Nope, it's on there. How does it know? Well, a side effect from creating what is now a virtual part is that the face that you selected gets this in place mate. So if you want to adjust where the table is, maybe you want it to for some reason be hanging off the edge, you can actually suppress this and start moving it around, but you got to be careful. So, you know, I'm going to save because this might potentially blow up everything, but this is for science, you know. We are scientists, mad ones at that. What happens if I suppress this in place and then I move it? Maybe like that. Oh, the horror. Well, nothing appeared to happen because I haven't hit rebuild yet. So let's hit Control B. Oh gosh, why is it doing that? And conversely, if you drag it out this way and rebuild, why is it so long? So this is the double-edged sword you have to consider when doing top-down assembly modeling. I don't think this can be reversed. Oh yeah, it can. It can be reversed. Okay, so the save was just because I was being scared. So what the heck? I guess is your question right now. You have to keep in mind that the way I defined this part is, if you recall, if I edit this sketch, it's always half an inch from the one edge. No matter if it's centered or if it's all the way over here, it's going to stretch that line and make this statement true. And that's the important thing. So what if you wanted just to do it this way to get the length, but then wanted to move it around? Can't I have both? Like, well, sure, there's a handful of ways to do that. I'll show you one. And before I do that, let me actually name this, because you can actually see this is at part 4 caret grooming table. So I haven't named it, so that's why it's part 4. And then grooming table, meaning that this actually doesn't have its own file. So we'll fix both of those issues. So to rename it, I like to hit F2 on my keyboard. And I'll name it tabletop. So now it turns into tabletop at grooming table. It's still virtual. That is, if I got searched everything and searched for tabletop, well, I guess in the app data because it's like being used, but if I close it down, it would actually not appear here. And apparently there's a DLL with tabletop. Don't know what that is. But yeah, it's good practice to actually save this out. So you right click and save part in external file is what you want. So same as path, okay. And now it's saved. Now it's saved the tabletop out in its own file. But now let's go back to our hypothetical. You know, if I suppress this and start moving this around, you'll still get all sorts of weird behavior like this. And that's because, you know, by taking that dimension from one edge to a different part in assembly, we created what's called an external reference. So what can we do? We can actually delete the external reference just straight up. Just go into the sketch, delete 0.5, and just give it an overall dimension. That will fix it. But an alternative method is, first we'll put this back. You can actually open up this part in its own window like this. There it is. And here, boss extrude, notice that it has a tiny little arrow. Arrow means external reference. And right now, it's actually watching the assembly to look for changes right now. You can stop that by right-clicking on the feature, go to External References, and you get two options, Lock All or Break All. Both will do the same, but the difference is Lock All is reversible, Break All is permanent. If you break something, if you break the reference, there's no way to reattach it unless you go back into the sketch and do it yourself. So I can't think of a single case where I actually recommend Break All. So what I like to do is Lock All. So now it's locked. So you can see it's pointing to a little asterisk. And now I can go back into my assembly, suppress this, move this wherever I want, rebuild. Nothing happens because it's saying, oh, I'm locked. I'm not going to be looking at those changes. So in that regard, it's, you know, that's definitely one way to get, it's one way to really control what your parts are doing. Though it's, you know, unnecessary because I just need it to kind of be like that. So now, how do I want to do this? Yeah, I might make this a little different from the OG one. Let me see if I can pull up the picture back here. Yeah, you can kind of see it there, but I think there's like a ball screw motor that kind of interfaces with a hinge there. But I think I'll probably take my own direction at this. Part of me wants to do another in context part. Vito, do you need to open the part though? I think you can gain assets via the browser menu, or gain access. Yeah. Oh yes, that's correct. Absolutely. You can if you open up tabletop, you can go to external references here. Good point. Yeah, it's just a lot of the times like I like showing the part environment itself. It's a lot more comfortable for people. Let me adjust myself. See my little. See my. I actually got this sweater new. I really enjoy it. My Benchmade butterfly sweater. All right. Yeah, actually, I might just. Let me pull a dimension from here so I know. Yes, so I can probably make that 7.5-inch plate with like a kind of bottle jack looking thing. I'll take my liberties with this. Yeah, because we're going on 2 hours of streaming now, which is more than I typically allot to CAD model the day. But you know, I'm also streaming. I'm also hanging out with my friends, so you know that time it's all rolled into one. It's good value time. Might even make this a multi-body part. So we'll start with this and get, you know, thin little extrusion like that. And then on the top plane, maybe do something like that. And that, make that a construction and make that infinite length, and then I can do that and just start making stuff up. I'm designing, baby. $1.5. And this, let's see how this goes. We want a revolve, but don't merge. And let's smooth this boy out. Smooth like my brain. Okay, do something like that. There's a kind of bottle looking thing. And then I'm gonna need like a little piston. Actually, I can probably punch the hole in first. How big is this? Let's just do it like that. I think here. So going back to the question of what is better, up to next or up to surface. So the way I would answer that is if both results in the same thing, I prefer up to next. And the reason I would choose up to next is because that's kind of like an intrinsic kind of end condition. You don't have to select anything to make it work. Whereas up to surface, you must select a surface for the end condition to work. It's like one more thing that can error out. Like if you lose that surface because you, let's say you filleted it away or something like that, you know, it's more errors that you have to go fix. Whereas up to next, you know, it's just, it'll just keep going till it gets to the other side. Where it's different is up to next only means one thing. Up to surface is much more flexible. So if I go ahead and extrude cut this and select up to next, it is only one thing. It just keeps going until it punches out of the other side of the body it's affecting only. It will not cut through the plate. It will only cut through the bottle up to the other side. Versus up to surface, well, if I pick this surface, well, that's kind of the same thing. But you also have the option to go down here, or, let's see if I want to be cheeky, up here. And that will actually make like a conical, like little point at the end. So up to surface, more flexible. Up to next, more robust. If they're the same, use up to next. But you'll know if you can't use up to next, because then it's like, oh, I got to use up to surface. So I guess that's the answer to that. So question, a sketch has the yellow check mark saying something is not perfect, but it's not telling me what. How to find what is missing, given I can't check each sketch constraint manually? Great question. And actually, let's do that. So, I'll just punch through the whole bottle. Who cares? No one's going to notice in my little animation. Well, let's start a new part. Save and call this the piston. And this piston, how do I want to do this? Because it's going to be relatively on the simple side. Yeah, let's try, we're going to make a ring. I'm going to revolve this. So how can I do this? So let's just take it one step at a time. Let's force my sketch. Now, let me get more interesting stuff in here though. Let's force my sketch to be yellow and then discuss what kinds of things we can do with it. So maybe make that 1.5. Ooh, this is thick. Make this 0.5 and make this 1 and make that way less. Say 0.75. Okay. And let's say, whoops, I made this coincident. And you get the ketchup and mustard. In this example, admittedly, it is on the simpler side, so you might be able to fix it by just looking at it. But what about larger sketches? Well, here's what you can do. So you see, yeah, you can see it in my stream. All the way at the bottom here says no solution found. You click on that, and then that brings you to your sketch expert. So just a single click on no solution found will bring you to here. So at this point, you can actually say diagnose. And it will figure out what relations or dimensions can be cut out to make the sketch happy again. So let's see the first solution it found. So it says, hey, if you just get rid of this horizontal, the sketch works again. Because this is coincident with this, kind of extends the line out. That's not what I want, so I can just hit this next button to see my other solution. And now it correctly found that, oh, this coincident, if you get rid of it, everything works again. And I guess you have to hit accept, but then you can kind of find in that way. Saying it's not overdefined, neither does it have conflicting dimensions. My yellow check mark is only visible in the browser. Interesting. I think that's a more complicated question then, and that's something I might have to actually see the example. Where I would start is, right click, what's wrong? Well, it also says here, what's wrong? And then once I have this message, I could properly advise you. But yeah, I think it would still be, if you haven't seen the sketch expert, that should definitely help you out. get a ring. And we gotta draw a stem, right? Okay. Point. Oh, I goofed up. I made this too small. Yeah, because I want to use an up to next, but it only works if it's completely bounded by the solid. I don't know how long this has to be, so I'm just going to guess 12. Up to next. Oh yeah, sometimes up to next and up to surface can give you different things if there's like two solutions. So if I do up to surface and pick this, okay, it gives the same thing, but sometimes it'll do something silly like go up to surface like over here. Just wanted to see if that would happen with this. No issues, I'll follow up on the Discord. Oh, great. Thank you. You reminded me. So, you know, if you're interested in what that Discord was, where you can ask all sorts of questions and stuff like that, here, I'll throw you the link. Copy. Here's where you can sign up for my for my Discord. We got about 50 members in there, you know, sharing all sorts of things, their problems, their cool stuff, memes. So, if anything, just go in for the memes. It's a great time. Yep, so there's that, and, you know, while I'm here, you know, the rest of my social medias. There you go. You know, link.tr.ee, so linktree/virtualflat. You will find you'll find like the rest of my stuff. Oh, your Virus. Oh yeah, good stuff. Yeah, so Virus has been particularly active. He's just been really pushing the boundaries of SolidWorks. VM, what you got for me? Rob, name a feature you think is very unappreciated. I recently looked for opportunities to use Jogline. It's awesome. I might be cheating on this, and I'll be honest. But here, let me there's one that I think needs to really get some love. And here, I got to set it up first. So, let me get rid of this hole. So, let's pretend that I modeled this hole with like a regular boss extrude. And I wanted to model the pin on the inside, like this. So I'll go ahead, model a pin. Might even just leave it like this, you know. So mid-plane, 3 inches, sure, why not? Uncheck merge result because I want the pin to be separate. So you have a situation like this, and you'll say, oh, I want a hole that perfectly fits this. You know, you could use extruded cut or something like that, but the indent command is probably my favorite underdog feature. It doesn't get used a lot, but I use it a ton now that I know its full potential. So why isn't it not used that much? Well, in its regular form, it works a little bit silly. So indent kind of turns things into sheet metal parts. So if I hit OK to this, and I section this, you see, kind of combine this, like it's almost like an aluminum, like kind of drawing, almost like a can that goes around this thing. So it's kind of weird. Why would you ever use this? Like, very rare case. But if you change it to cut, then it becomes the greatest thing since sliced bread. So cut indent means that basically where this thing is crossing through any solids, it cuts out a perfect hole for it that will update with changes pretty much. So if I change this to 0.625, hit rebuild, you know, changes the shape. So you might be saying like, well, yeah, I can do that with the cut extrude, just reuse the sketch, right? But it does it with the body. So you know, you could have like a mold of like a plastic part, and with this, you can actually, you know, change the entire part around, and the entire mold will change. So it's just, you know, it's just, that's probably one of my favorite features. Also, if I want to have the rod through the ring, how would I do that? Two-side extrude. Oh, are you talking about a mid-plane? So, like, normally it comes out the one end because it's just blind, like this. But if you put it to mid-plane, it basically splits the difference and puts one on each side. Let me know if that's what you were asking there. Just kind of like that. Or, of course, you could go blind on one end, direction to blind on the other end. And then if you needed something like, you know, 1 inch on one side and 3 inches on the other side. Plenty of ways you could do that. Alright, so going back to our... Cool, generate the negative mold real time. Yeah, right on. Yeah, that's one of the methods you can do that. There are even more like optimized like mold tool stuff, like if, you know, for closing off holes and stuff like that. It's wild. So that's a deep rabbit hole. I'm telling you, you could do this for years. You could do this stuff for years and just never get to the bottom of like modeling in SolidWorks. Actuator. Let's put that. So this with that, and then front plane of that with front plane of this, so that should have that in there. And then lastly, I want this. I was talking about the vertical rod where you face some difficulty in the up to surface issue. Oh, so I would probably use the starting plane condition. So instead of starting from the sketch plane, you can start from like an offset, or if you make a plane before, you can actually pick that plane and then go mid plane from there, or something like that. What about a stream using Surface Module? Yeah, of course. Honestly, I'm feeling very comfortable with these streams right now. Oh, I goofed up. I didn't want this last one. Yeah, I'm feeling very comfortable with these streams. I think 3 times a week is pretty good for me. So, you know, if all goes well, you know, I'm probably going to, you know, keep streaming past March and hopefully do this just like as a regular thing. So there'll be plenty of more of these to come. Piston. So there, and then this. So this should move it into place. Concentric. So I do that. Yeah, what's interesting is... Okay, I realized something. So, in real life, the actuator doesn't move like that. It doesn't wiggle back and forth. But it needs a degree of freedom because the point where it's attaching to is moving in this arc. That is what this hole is for. So I need this whole thing to pivot. Okay, let's make some edits, and then we're pretty much home free. Before I do that, so that stays, that stays, that stays, this dies. And by dies means turned off. So front, so go ahead and change this to not be equal anymore. And I'll change that to 7. So it's going to be slightly rectangular. Nope, needs to be shorter than that. 6. Shorter still. This is actually the use case for for top-down assembly modeling to prevent potato stuff like this. But it's all cool. Or actually, screw it. Get rid of it. Let's model something else. Like this. Let's model like a tab. Okay, 0.5. Centered about here. Stretching out about 1 inch, like that. And that needs like that. So in terms of a circular loop, I can only consider the first intersection, but we need the second intersection. I might have to try that again later to see exactly what you're referring to. Although you're coming near to 507, what's next? There's a lot of 507 left, so there's going to be that, but you know, if I model every single thing from 507, I'm just gonna keep looking around and just like, you know, see stuff around my house or just do research on like different amazing mechanisms that people use and start modeling those. So hold up, add a higher pair between the actuator stroke and the horizontal support above. Just a dome on the stroke and then a tangent mate will do it. Yeah, I could do it that way, but you know, I think this way we'll actually like use the actual pivot, which I think is that's like what it actually does. And I'm just gonna delete the face of this fillet. Okay. So now I can put this here and here. That locks into place. And there we go. So now the actuator has a degree of freedom, its rotational degree of freedom, that allows it to actually go through with its stroke. Yeah, I didn't model any pins, but you know, I think that's going to be trivial and yeah. So I'd say, you know, let's save, because actually a lot of times when SOLIDWORKS crashes is when I'm putting appearances on for some reason. So saving is good. Paint, some black spray paint. Control Shift C copies appearance, and I want to paste. And it's going to paint these all black, and then the top can be wood. Just like make it look like something. There we go. Oops. Save. And then I think like a dark wood, just like the real life one. Organic wood. Is that the end grain? Yeah, I put the end grain like a dingus. There we go. Looking pretty good, I would say. So I'll just leave it like this. Is there anything else I want to do with this? Saving is one. But I think I'll bring things to the middle and go to my motion study. And this should be pretty trivial because it's just putting a motor on that actuator, and this whole thing should run, hopefully. So motor, linear. So here's the important bit. Motor location along this axis going the other way. And here's the important bit. Recall that as it goes through its motion, the actuator is doing this, right? So in order to prevent it from locking up, because I can't just say go perfectly straight up, it needs to be just going out of the actuator body, no matter what orientation that it is. So that's what this box is for. So I select the actuator body with this, so it knows that it is measuring that direction with respect to the orientation of this body. And then I think I might just put data points. Let's do displacement. And let's do Oculus spline. Let's get some of these up and we'll start filling it. So 1 to 10. So let's say that I think 12 is going to be far too much. So it starts at 0, then goes to 12, and then back down. Well, actually, I don't have to do that since it loops. Yeah, I might... Can I select multiple rows? I have too many rows. Delete. 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 Let's make that... So from 0 to just to the end of 2. Yeah, let's see. Well, I actually do. I'm changing my mind. Yeah, because and this is just a quirk of Camtasia, the video editing software that I use. It doesn't know how to reverse video, which is potato. Well, let's do that. Oh, I knew it. Way too much. It works though. It works. Yeah, the way it's acting right now, it's a puppy catapult more than a more than a grooming table. So we'll fix that here. Vito asking, hey, are you familiar with inbuilt SOLIDWORKS Cam, or do you use third-party stuff by like Mastercam? I actually started learning SOLIDWORKS Cam. I don't think I know it well enough to like teach it on stream. So yeah, I don't think I can be a resource for that package. Yeah, it comes free with SOLIDWORKS 2018 Plus. I think if you're on subscription, so that's a caveat. Oh yeah, click speed. Yeah, I can do that, but you know, just a stroke is just way too much. Cut that by 2/3. There we go. That's a saner number, and I need to actually see what's going on. Replace. I think that's pretty good. Also has oh yeah, within SOLIDWORKS, yeah, there is. It's this thing, yeah, reciprocate. But a quirk of it is I've never been able to save video with that setting. So even if I put reciprocate, it's only for like this viewer. Like if I hit save video, it only puts the frames in order. Yeah, and if Camtasia was able to just reverse the video, I would have done that. But yeah, there is a reciprocate and loop and stuff like that. But for some reason, when you go to save it, there's no like, yeah, there's no options here. It's like, oh, save it as reciprocate or anything like that. I think that's the main issue. So let's first bump the frame rate on this puppy to 60. Okay, the ding of happiness. And I'm going to get rid of these phantom edges. So display tangent edges removed. So we'll have something like this. Oh, even in okay, so that's news to me. Keep in mind, I do have an old version of Camtasia. I have Camtasia 2018. Yeah, and when I was looking for it, I searched it up, and basically there was like a forum saying like, "Oh, it's not here." But I could be wrong, and I'll probably look into that again because if what you're saying is true, that will save me a lot of pain in the future. I mean, most of the time, you know, it's not too bad to it's not too bad to just have SOLIDWORKS do the reciprocating for you, but sometimes it really is a pain. Entire animation. All right. Yeah, and I know I can remove the arrow, but I do like the fact that, you know, even though the actuator is kind of obscured, you can actually see where the force is being applied, which I think is very cool. Oh, see you, Sebastian. So glad you took out of it. You know, the stream's probably coming to an end here as soon as I review the footage here. So thanks for sticking with me this whole time. Pleasure to have you. And so let us go to Window, open up this folder, and take a look. Open with Windows Media Player. I'd say that's a winner. I really like the way that came out, so I think I'm going to work with this. It is a little off to the left a little bit, but that can easily be fixed in Camtasia. So, whoops, I killed the music. Just kidding, music's back. Yeah, so, you know, with that, I think I'm going to end the stream there. You know, sometimes I do like to play games, but this has been a pretty long stream, pretty informative stream. I'll probably go through this VOD and, you know, clip out some of the best parts. You know, you guys' questions were so good. So, yeah. So I think that's going to be all for tonight. The next stream is going to be scheduled for... Today's Thursday, isn't it? Yeah, this Saturday at 7 p.m. Eastern Time. And, yeah, I don't know what I'll have for you, but we'll find out. Take care, guys. Take it easy.